Before we look at practice problems, let's clarify what a misleading graph really is. On the SAT, the data themselves are often correct. The numbers are not fake or wrong. The problem is how the graph is drawn. By changing the scale, trimming an axis, or using uneven intervals, a graph can make small differences look large, or large differences look small. That's why you should never rely on first impressions. When you see a graph on the SAT, pause and check the axis and the scale before interpreting the data. In this lesson, you'll learn how to spot these misleading features and avoid being fooled by the way a graph looks. Now let's give names to the common ways graphs can mislead. First, truncated axes. When an axis does not start at zero, small differences can look much larger than they really are. Second, different scales. The same data can appear to change dramatically, or barely at all, depending on the scale that's used. Third, uneven intervals. When values are spaced unevenly but look evenly spaced, the rate of change can be misinterpreted. On the SAT, these features don't mean the data are wrong. They mean you need to slow down, check the graph carefully, and question your first impression. Here's one of the most common ways graphs mislead on the SAT: truncated axes. Look at the top graph first. At a glance, category C appears much higher than A or B. It looks like a big difference. But now check the vertical axis. The axis does not start at 0. It starts near 90. When an axis is truncated like this, small numerical differences can look much larger than they really are. Now compare it with the graph below. This graph uses the same data, but the axis starts at 0. Suddenly, the difference between A, B, and C looks much smaller. The key point is this: the data are the same, but the visual impression changes. On the SAT, always check where the axis starts before drawing conclusions. Now let's look at another common trap on the SAT: different scales. Start with the top graph. The line looks like it's rising sharply over time. It feels like there's a strong upward trend. But before reacting to the shape of the graph, check the scale. The vertical axis is very narrow. When the scale is compressed like this, even small changes can look dramatic. Now compare it with the graph below. This graph uses the same data, but the vertical scale is much wider. Suddenly, the trend looks much smaller and more gradual. The key idea is simple. The numbers did not change, but the story did. On the SAT, always compare scales before comparing trends. Now let's look at the third common trap on the SAT: uneven intervals. Start with the top graph. At first glance, the line appears to rise very steeply in the middle. It looks like the value is increasing much faster at that point. But take a closer look at the horizontal axis. The values are not evenly spaced, even though they appear evenly spaced on the graph. When unequal intervals are shown as equal, the slope can be misleading. A section of the graph can look steeper simply because more change is squeezed into less space. Now compare it with the graph below. Here, the same data are plotted with the correct spacing on the axis. The trend is much smoother, and the rate of change is easier to judge. On the SAT, remember this rule: a steep line does not always mean rapid growth. Before we move on to practice, let's pause and summarize what you've learned so far. On the SAT, misleading graphs are not about incorrect data. They are about how the data are presented. We've seen 3 common traps. Truncated axes can make small differences look big. Different scales can make the same data look dramatic or insignificant. Uneven intervals can distort the rate of change. That's why this order matters. Before you read any statement, first check the graph itself. Look at where the axis starts. Compare the scale, and make sure the intervals are evenly spaced. Once the graph is clear, then, and only then, evaluate the statement. Now, let's apply these rules to real SAT-style questions. Here is your first practice question. Take a look at the graph and think carefully. What is the main issue with the graph shown? Focus on how the data are displayed, not just the values themselves. Let's go over the answer to this question. The correct answer is C. First, notice that the data values themselves are reasonable and consistent. They increase gradually from A to B to C, and there is no sign that the numbers are incorrect. However, the key issue is how the graph is drawn. The vertical axis starts near 70 instead of 0. When an axis is truncated like this, small numerical differences can appear much larger than they actually are. This exaggerates the visual differences between A, B, and C. That's why choice C is correct. The vertical axis exaggerates the differences. Now let's briefly look at why the other choices are incorrect. Choice A says the data values are incorrect. But the values increase smoothly and show no inconsistency, so there is no evidence of an error in the data. Choice B claims the categories are mislabeled. In fact, categories A, B, and C are clearly labeled and ordered correctly. Choice D suggests using a different type of graph. A bar graph is actually appropriate for comparing categories. The problem is not the graph type, but how the axis is scaled. On the SAT, always remember to check how a graph is drawn before questioning the data itself. Here is your next beginner practice problem. Take a look at the line graph shown. Which statement is best supported by the data? Be careful, the vertical axis does not start at 0, so the visual changes may look larger than they really are. You have 60 seconds. Pause the video and think carefully before choosing your answer. Alright, let's go over the answer to question 2. The correct answer is B. Look at the overall pattern from year 1 to year 5. The value starts at about 85 and ends around 90, so the general direction is upward. But notice one important detail: the value drops from year 2 to year 3. That single dip matters, because it prevents us from making stronger claims like, strong throughout, or, it increases every year. That's exactly why choice B is best. It says there is an overall upward trend despite some fluctuations. It matches what the graph shows, an upward direction, but not a perfectly steady climb. Now, why not the others? A says, rapidly, but the changes are only a few points. C says, slight, which is subjective and not something the graph proves. And D says the increase gets larger each year, which is false because the graph goes down once. On the SAT, choose the statement that is accurate, cautious, and supported by every part of the graph. Here is an intermediate practice question. You are shown two graphs that display similar patterns, but one appears much more variable than the other. Look carefully at both graphs and think about what makes graph A look more variable than graph B. You have 60 seconds. Pause the video and choose the best answer. Now let's go over the explanation for this intermediate level question. The correct answer is A. At first glance, graph A appears much more variable than graph B. The line rises and falls sharply, which can make the changes seem dramatic. However, the key issue here is not the data itself, but how the graph is scaled. Graph A uses a much narrower vertical scale than Graph B because the y-axis covers a small range of values. Even minor changes in the data are visually exaggerated. This makes the fluctuations look larger than they really are. Now compare this with Graph B. Graph B uses a wider vertical scale, so similar changes in the data appear smaller and more stable. As a result, Graph B looks smoother, even though the data follow a similar pattern. This tells us something very important: the data in both graphs are actually quite similar. What changes is the visual impression, not the numbers. Let's briefly review why the other choices are incorrect. Choice B claims that Graph A contains more extreme values. This is not supported by the data. Graph A's values are not unusually high or low. Choice C suggests that Graph B removes important fluctuations. But the fluctuations are still there, they are simply less emphasized visually. Choice D focuses on growth rate, but this question is about visual exaggeration, not how fast the data increase. So the correct explanation is that Graph A appears more variable because its narrower vertical scale exaggerates small changes. Now let's look at an advanced level question. Take a close look at both graphs. The data may look similar at first, but the way the graph is drawn can change how we interpret the trend. Which statement best explains why this graph may be misleading? You have 90 seconds. Pause the video and take your time to analyze the axes carefully. Now let's review the answer. The correct choice is D. This graph is misleading because the horizontal axis is not evenly spaced. The labels move from 0 to 10, 10 to 20, then jump to 50 and 100, but the graph places those points as if the gaps are equal. That visual choice changes how we read the slope. The line appears to speed up in the later years, even though the actual rate of change does not suddenly increase. This is a classic SAT trap. The data themselves are correct, but the spacing on the axis exaggerates the rate of change. That's why choice A is not enough. It describes the trend, but it doesn't explain what makes the graph misleading. B is wrong because the values are not irregular, they rise overall. And C is incorrect because no data points are missing. On the SAT, always check whether the axis spacing matches the numbers before trusting what the slope seems to show. Let's slow down and clearly review the key takeaways. First, always check the axis scale before you interpret a graph. On the SAT, many visual traps disappear the moment you read the numbers on the axes instead of trusting the picture. Second, uneven spacing matters. When time or values jump unevenly but are drawn with equal spacing, the rate of change can look faster or slower than it really is. Third, remember that a graph can look dramatic even when the data change slowly. A steep-looking line does not automatically mean rapid growth. The scale controls how your eyes perceive the data. And finally, understand what the SAT is really testing here. These questions are not about hard math. They are about attention, skepticism, and discipline. If you pause, read the axes, and question the scale, misleading graphs stop being traps and start becoming easy points. Don't ask, what does this graph look like? Ask, what do the numbers actually say?